Welcome to Astronomy Daily, the podcast, your celestial guide to the latest happenings in the boundless depths of space. This episode is a cosmic journey through the most recent astronomical discoveries and milestones that continue to shape our understanding of the universe. Today, we'll delve into the triumphant revival of the Hubble Space Telescope and the mysterious challenges faced by NASA's very own exoplanet sentinel, TESS. We'll probe the concerning anomalies discovered in NASA's Artemis 1 mission and explore what the future holds for lunar exploration. Strap yourselves in as we ride the high of success with NASA's HighSea flare sounding rocket, shedding unprecedented light on the vibrant drama of solar flares. We'll unravel the cosmic mystery behind a peculiar binary star system that defies our established models of stellar evolution. And finally, we'll travel close to home with NASA's Lucy spacecraft to uncover the youthful secrets of an asteroid moonlet, changing what we thought we knew about our solar neighborhood. Prepare to embark on an interstellar voyage where the wonders of the cosmos come alive. Stay tuned as we navigate through the stars right here on Astronomy Daily, the podcast.
The Astronomy Daily Podcast.
In a space of joy and caution, NASA's venerable Hubble Space Telescope has been restored to full functionality, once again peering into the depths of the cosmos after a suspenseful week operating in safe mode. Engineers skillfully resolved a perplexing gyroscope glitch that had seized Hubble's gaze on April 23rd, an issue which alludes to the telescope's storied past and its ongoing tale of technological resilience. These gyroscopes are like celestial compasses, essential for the telescope's precision, and revivifying them was a nod to the legacy of Hubble's 34-year survey of the stars. As each of Hubble's instruments hummed back to life, the scientific community sighed in relief, celebrating the continuation of a mission that has profoundly expanded our understanding of the universe. Yet, as Hubble triumphantly resumes its cosmic watch, concern lingers for its planetary sentinel sibling, the transiting exoplanet survey satellite, TESS. In a striking coincidence, TESS 2 suspended its search for distant worlds on the very same day as Hubble's safe mode initiation. The roots of TESS's operational pause remain shrouded in mystery, with investigation efforts fervently underway to decode the cause of the satellite's silence and reactivate its mission to catalog extrasolar realms. Such interruptions are not new guests to TESS's journey. In April alone, a separate incident had coerced the exoplanet hunter into standby, a scenario from which it briefly emerged only to relapse into stasis once more. NASA's probe into whether these incidents share a common thread is a testament to the iterative pursuit of discovery, a pursuit that, despite setbacks, marches inexorably onward. Reflecting on milestones, both Hubble and TESS have recently crossed anniversary thresholds, marking places in time that stand as testaments to human ingenuity and the ceaseless quest for knowledge. TESS commemorated its 6th year in orbit on April 18th, a mission launched atop the power of a SpaceX Falcon 9 and entrusted with the grand task of unveiling the secrets of distant worlds. Hubble, a titan among telescopes, observed 34 years in space just 6 days later. As TESS lingers in a tentative state, NASA issued an expression of interest call on April 30th, seeking guidance on scientific objectives to prioritize during its 3rd and 4th extended mission periods. A clear signal of NASA's commitment to TESS's mission, despite its current operational challenges. Such anniversaries not only celebrate the past but invigorate the future. With extended missions unfolding, Hubble continues to unfurl the mysteries of the universe, while TESS, ever the intrepid explorer, patiently awaits its return to the frontier of exoplanetary science. The dance of these celestial watchkeepers, one in steadfast observation, the other poised to resume its watch, is a reminder of the delicate yet determined nature of our cosmic odyssey. Shifting gears, let's delve into the Artemis 1 mission, a critical precursor to returning astronauts to the moon. However, with great ambition comes great complexity, and recent findings suggest there are obstacles to overcome. Notably, the Orion spacecraft's heat shield encountered unforeseen challenges during its lunar voyage. Upon re-entry to Earth's atmosphere, over 100 areas on the shield displayed unexpected wear, raising concerns over the materials used to protect the craft from the fiery descent. A sight to behold as Orion re-entered, its heat shield bore the scorching marks of its journey, jettisoning charred material, some of which clung briefly to the capsule's windows. NASA is proactive in its approach, modifying the heat shield to prevent recurrence. Yet, the concerns extend beyond the shield itself, touching on the bolts connecting the crew capsule to its service module. Adjustments are being made to counteract unwanted melting around these crucial components. Moving inward, the electrical distribution anomalies that surfaced cannot be overlooked. The spacecraft's transit was marred by episodes affecting power management, suspected to be induced by radiation. This revelation led NASA to craft operational workarounds, while caution is advised against potential loss of redundancy or even propulsion and pressurization, highlighting the critical importance of a permanent hardware solution. The Office of Inspector General's report pulls no punches. It stresses the need for NASA to closely monitor the process from development to testing of the Artemis II hardware. For the safety of future crew members, it is imperative. This methodical advancement, however, is not without its temporal costs. Delays have arisen, which in turn impact subsequent missions. As anticipated dates are revised, with Artemis II now slated for September 2025, the Artemis III mission may not grace the moon until the latter half of the decade at the earliest. It's worth acknowledging the unforeseen latency in the communication sphere as well. A hair-raising 4.5-hour loss of connection between Orion and Mission Control, courtesy of an outage at a deep space network facility, serves as a reminder of the vast and perilous nature of space exploration. The report from the Inspector General's office lays bare the challenges on our path to the moon. It underlines the significance of meticulous preparation. Our pursuits in the cosmos are as fraught with peril as they are propelled by hope and perseverance. With each test and trial, NASA inches closer to safeguarding future lunar explorers, ensuring that the precipice of space exploration is met with unwavering resolve and robust technology. In a solar spectacle of truly unprecedented detail, NASA's high-resolution coronal imager flare mission, affectionately dubbed HighSea flare, has given scientists and astronomers a never-before-seen view of solar flare intricacies. After a thorough preparation period and following its predecessor's flight several years prior, the HighSea flare mission blasted off from Alaska's Poker Flat Research Range aboard the Black Brant 9 sounding rocket. It is no small feat that the advanced low-noise cameras, precisely crafted at NASA's Marshall Space Flight Center, were part of such a revolutionary experiment. The aims were ambitious, yet crystal clear, to peel back the layers shrouding the immensely energetic phenomena of solar flares. Under the leadership of Marshall, and with Sabrina Savage at the helm as principal investigator, this campaign marked the first of its kind, leveraging sounding rockets specifically to capture the fleeting but fierce dance of solar flares. With a suite of state-of-the-art instruments, including Kool-Aid, Capri Sun, and Saxi, the hope was to tease apart the mysteries of the sun's tantrums. The meticulous integration of the payload and the intense observational planning in New Mexico crescendoed in Alaska, where a strict launch window demanded near perfection in timing and conditions. Every morning of the 2-week window, a 5-hour marathon ensued to prepare the rocket. Hours more were spent with eagle eyes on solar data for that ideal flare, a C5 class or higher. The dedication of the team was palpable. The tension that gripped them as they awaited the sun's display was nearly as electric as the flares they sought to study. And finally, the sun complied, gifting a gorgeous M-class flare as the campaign neared its conclusion. Launched 1 minute shy of a tandem mission, the HighSea flare rocket soared, stabilizing its sensors and cameras as it carved through the atmosphere with precision. 5 minutes of unparalleled data were collected before the journey back to Earth, the rocket resting in the Alaskan tundra, awaiting retrieval, and the subsequent awe-inspiring analysis. The success of HighSea flare is nothing short of monumental. The raw, unfiltered data brought forth are indeed beautiful, but the methodology that brought us here is worth its own spot in sunlight. A new algorithm predicting solar flare behavior ensured the rocket launched at just the right moment. It was a gamble against nature's unpredictability, warranting a strategy no one had dared to attempt prior. But as history smiles upon the bold, HighSea flare now proudly fortifies that adage. The critical insights gleaned from this mission will undoubtedly reverberate throughout solar research, as the data from Kool-Aid and other instruments already seem to exceed all expectations. And it's with bated breath that we, the cosmic community, wait for the full unveiling of knowledge from this extraordinary mission. It's a testament to the ingenuity at NASA's Marshall Space Flight Center and an inspiration, sparking curiosity about what remains beyond our grasp in the boundless expanse above.
The Astronomy Daily Podcast.
In today's episode, we're delving into the celestial drama hidden deep within the Dragons Egg Nebula, a name as evocative as the mystery it harbors. At the heart of this nebula lies a binary star known as HD 148937, an astronomical duo surrounded by a cloud of enigmas, challenging our understanding of stellar evolution. The twins nestled inside this stellar cocoon are young, hot, blue giants, their combined radiance visible through even modest telescopes. But take a closer look and things start to unravel in the most peculiar ways. To unwrap the mystery, let's consider the nebula that enfolds these stars. Typically, nebulae born from stellar nurseries are rich in molecular hydrogen, but the Dragons Egg Nebula presents us with a conundrum. It's laced with heavier elements such as oxygen, nitrogen, and carbon, elements usually forged in the crucible of ancient dying stars, which our two characters most certainly are not. Dr. Abigail Frost of the European Southern Observatory has been examining the physics of this binary pair and the nebula that embraces them, and she has noticed some stark irregularities. One puzzling anomaly is the magnetic field enshrouding the larger of the two stars. You see, a powerful magnetic field in a massive star like this is quite the cosmic outlaw. Our current understanding says there shouldn't be enough chaotic roiling within these stellar titans to generate such a field, and yet it unmistakably exists. This magnetic star also spins at a pace that defies the slowing effects of its own magnetic grip, an unexpected and thrilling twist to our stellar tale. In a profound twist, evidence points to the larger star being significantly younger than its companion by about 1.5 million years, which throws a wrench into the gears of astrophysics. Both should have emerged at the same time from the same interstellar womb. Such inconsistencies hint at a remarkable history, seemingly inscribed within the very fabric of the nebula itself. So how does one reconcile these contradictions, these breaches against the laws of stellar physics? Dr. Frost and her team believe the answer lies in a cataclysmic event, an event so extreme it stretches the imagination. They propose that the system was originally not a duo, but a trio of stars. In a twist of fate aligning gravity, velocity, and sheer chance, two stars gravitated towards each other, colliding with stupendous force. This cosmic clash not only forged the magnetic field and sent the larger star into a rapid spin, but it also expelled the heavier, fused elements, casting them out to fabricate the nebula we observe today. In the aftermath, the collision and subsequent merger of the two stars would result in the apparition of youth seen in the larger star, a deception of astronomical proportions, and the third star, previously a more distant spectator, now finds itself locked in an orbital dance with the newly unified pair, creating the binary system central to the Dragons Egg Nebula. Each of these observations, alluding to a stellar story of destruction and rebirth, offers support for the hypothesis of a triple star system reduced to a binary through a violent merging. The magnitude of their discovery is monumental, as it affords us a rare glimpse into the chaotic, yet inherently beautiful, life cycles of the stars, inviting us to reconsider what we thought we knew about the heavens. Turning our sights now to a celestial pair in the vastness of space, let's recount a tale of a recent paradisiac discovery by NASA's intrepid Lucy mission. In the deep cosmic sea where astral bodies dance, a near-Earth asteroid named Dinkinesh has revealed itself to not be a lone traveler, but rather accompanied by a diminutive moonlet, an affectionate partner dubbed Salam. The exhale of awe that followed this revelation was countered by a collective inhale of curiosity. Just how old might this pairing be? Scientists, wielding a blend of astute observation and meticulous computation, have deduced that Salams Genesis from its larger companion occurred a mere 2 to 3 million years ago. In the time-worn clockwork of the solar system, Salam is but an infant, its cradle still swirling from the dusts of its creation. This asteroid's tender years stand in stark contrast to the grand age of the solar system we call home. Colby Merrill, a doctoral candidate dancing with the shadows of these rocky bodies, led the charge in this cosmic detective story. His technique was innovative, eschewing the well-trodden path of crater counting for a dynamic simulation of orbital mechanics, encapsulating a myriad of scenarios within a digital crucible. The figures sustained the youth of this cosmic child, Salam, possibly younger than the skeletal echoes of our own ancestry, embodied by the renowned Australopithecus afarensis. As Salam's narrative unfolds, we are reminded that within the asteroid belt's cacophony lies a symphony of binary systems, Salam and Dinkinesh being just one of the estimated 15% of such duos. Each celestial dance tells a story, and in Salam's tender beginnings, we see a narrative that deepens our grasp of asteroidal kinship and concoction. The Lucy mission presses onward in its grand voyage, a carousel ride through our solar system's recesses. This journey of exploration continues not just for the craft, but for us all, each revelation a verse added to the grand chronicle of our universe. As the cosmos whispers its secrets, we listen, etching new understanding into the annals of our collective knowledge. And that wraps up today's journey across the universe with Astronomy Daily, the podcast. Thank you for tuning in and indulging your curiosity with the latest celestial findings and space explorations. We've traversed from the recovery of NASA's venerable Hubble Space Telescope to the youthful dance of asteroids in our own solar neighborhood, testament to the boundless wonders above us. To continue the adventure and keep your stargazing spirit alight, I invite you to visit our website at astronomydaily.io. There, you'll not only find more riveting space news, but you can also listen to past episodes and, most crucially, become part of our cosmic community by signing up for our free daily newsletter. Don't forget to extend this celestial dialogue into the digital space by following us on X, formerly known as Twitter. Just search for Astro Daily Pod and hit that follow button to join our constellation of followers, eager for their daily dose of astronomy. Until next time, keep looking up and questioning the stars. This has been Astronomy Daily, the podcast. And I'm Anna, your host, signing off with a reminder that the universe is always just a podcast away. Clear skies and cosmic dreams, everyone.